Hi Math 95. In this video we're going to talk about this guided learning activity where we work out learning to complete the square. So I handed this out in class, and as promised I'm going to in this video walk through this activity with you to cover this idea of completing the square. This again is going to be another way for us to solve quadratic equations. So let's work over here on our little board for a second. Remember in class today, on Friday, we talked about solving equations, remember, that are quadratic. They look something like this, right? And today we covered what was called the square root property, right? We called it SRP, right? And the square root property basically just allowed us a generalized way of saying that if we have something like box squared equals a number, right? If we have that, then we can write box is equal to the square root of number, or we can say box is equal to negative square root of number. Okay, that's the square root property. And that is one way that we can solve quadratic equations. This activity here is going to give us another way of solving these quadratic equations, and this is especially useful for when this trinomial over here on the left side is prime. Okay, especially useful for those kinds of situations. Because what we're going to do is we're going to take a prime trinomial, mess with it a little bit so it's no longer prime. So in this activity over here, let's work out example 1 where we just practice using the square root property, right? So let's work through example 1. And so here we want to solve the equation x plus 2, the quantity squared, equals 9. Notice this is a perfect setup right here for using the square root property, because it does say, in fact, something squared is equal to a number. So that something, remember, is just this box, right? So this says box squared equals 9. So that means that box, or x plus 2, could equal the square root of 9, or x plus 2 could equal negative square root of 9. Okay, and since the square root of 9 is a nicely simplified number, it's 3, right? Then we get these two statements about x plus 2 being plus 3 or minus 3. And now let's just solve for x. So x could equal 1, or x could equal, if we subtract 2 from both sides, minus 5. Okay, so here are our two choices. Our two solutions for that first example. Now let's work through example 2 where we discover the process for completing the square. Okay, so let's get a new sheet of paper. This is pretty cool. Whew, that's pretty neat, huh? Okay, in example 2, the idea is we want to take a binomial or a trinomial on the left side and modify it. So we start out with something like this: x squared minus 8x minus 9 equals 0. And first of all, is this one factorable? Let's see. Let's see if we were able to factor it. So let's see. If we were able to factor it, it would be x and x equals 0, right? Okay. Factors of 9 that can make 8, that would be 9 and 1, right? Opposite sign. So this one actually, does this one look like it factors nicely? This one actually does factor nicely, right? Because we get x minus 9 equals 0, or we get x plus 1 equals 0, right? So here we get x equals 9, or we get x equals negative 1. So in this case, we can factor this one. We can solve this quadratic equation by factoring, but let's see if we can do something slightly different and do what's called completing the square. What's nice about already knowing our answers is that when we get to the end of this process, we'll know if we did it correctly or not, okay? But the process that we're going to do, this completing the square, is going to apply whether we're able to factor it or not, right? So let's see. In the beginning part of this, what we want to do to complete the square, the first step is going to be to get only the terms that have x's all by themselves over here. So this is part A, right? We want to move the constant term over to the right and leave a little blank where it used to live, right? Leave all the stuff that has the x's over there on that side, right? Okay, so we have x squared minus 8x, leave a space, equals 9, right? That just means we added 9 to both sides. We moved the 9 over to the right side. This may seem counterintuitive because previously to this we have trained you to make it equal 0, right? So this is a little counterintuitive, but let's just play along for a second. Okay. Now the idea is, what we want to do is put a number right here that would turn the resulting trinomial over here into a perfect square thing, right? Where it would be a binomial that lives on the inside, two terms right here, okay? So what kind of number do I have to put right here where that little space is so that this thing would factor into square of a binomial? Let's see. The way we do this is to take this middle number right here, this -8. We take -8 and we divide it by 2 and we square it. Okay, and that's going to be the process always for completing the square, is that we're going to take the middle number, the number that lives in front of the x, we're going to divide it by 2, and then we're going to square it. Okay, and that's the number that goes right there in that space. Okay, so let's see, -8 over 2 is -4. When I square it, I get 16. That's the number I put right there. Okay, but because this is an equation, the number I put over on the left must also be added to the right side of the equation. Otherwise, I've changed the equation. Okay, and that's exactly what has happened in part B. That complete the square instruction right there is what I just did, right? I took this number in front of x, divided it by 2, and squared it. Okay, and that number gets added both to the left and right sides of the equation. But what's nice about this is that, again, this resulting trinomial will become a square of a binomial. What does it factor into? It factors into x minus 4, the quantity squared. And if you don't believe me, factor this trinomial out and check it. You'll agree with what we get. Okay, so let's rewrite our line, what we have as x minus 4, the quantity squared, equals, and what do we get on the right side? 9 plus 16, which is 25. Okay, this right here, this equation is a perfect candidate for the square root property because again it says something squared equals 25. So let's apply the square root property. And what we get is x minus 4 equals the square root of 25, or x minus 4 equals negative square root 25. Okay, and these simplify nicely, so x minus 4 equals 5, or x minus 4 equals negative 5. So x equals 9 or x equals negative 1. And isn't that what we got before? Yep, when we factored it, that's exactly what we got before. So we know we did it correctly, right? And so that's the idea with completing the square, is performing this step right here, right? This step, right? Where we have to think about what we want to add on either side of the equation so that we turn the thing on the left, the trinomial, into a square of a binomial, that kind of an idea. So we can apply the square root property right there. Okay, so let's try another one like this. I think there's more on the back side, right? And there's a cute little joke here, right? Of course, with these fun little activities, they always have these little jokes on there from this activity book that I get these from. Okay, so let's get a new page and let's try this next one. So we've got x squared minus 10x plus 5 equals 0. Okay, and if you want to at this point, you can pause the video, you can stop the video, and you can try this one yourself, and then you can start the video again and see if you did it correctly, right? Because I'm going to do it right now. So pause if you like, and when you come back, I will say, hello! Okay, so let's see. The first thing we have to do is move the constant term. That's the first step. So let's get that 5 on the other side. So I've got x squared minus 10x, leave a space, equals minus 5. Okay, now remember what we do next. To figure out what goes in this spot right here, and then also over here, because it has to be on both sides, I'm going to take the negative 10 that's right here. I'm going to divide it by 2, and I'm going to square it. Okay? And what does that equal? That equals, let's see, negative 10 over 2 is negative 5, and when I square that, I get 25. Right? So that's the number that goes here, plus 25, plus 25. Same thing on both sides. Okay? So now, what do we get when we factor that left side? When we factor this trinomial that we have right here, what do we get? It factors into x minus 5, the quantity squared. Again, if you don't believe me, write out the double parentheses and factor it for yourself. And on the right side, we get 20. Okay? This, again, is a perfect candidate for square root property because it says something squared equals a number. So I can say x minus 5 equals the square root of 20, or x minus 5 equals negative square root of 20. By the way, we could compress this a little bit because I could write this as 2 two lines all in one as x minus 5 equals plus or minus the square root of 20. That's totally okay. Remember, we've talked about that plus minus notation. Okay, and I don't think that that radical, that square root of 20, is simplified because 20 can be written as 4 times 5, and 4 is a perfect square. So let's see, if we have x minus 5 equals, let's see, this would be plus or minus, the 4 would come out as a 2, so that's 2 square roots of 5. Okay, and our last step is to solve for x, so x equals 5 plus or minus 2 square roots of 5.